Hello and welcome back. In this video we will start section 5.5, which is all about graphing inequalities. So let's start out by looking at graphing an equality. So if we have x plus y is equal to 2, when we want to graph this, we normally solve for y. If I subtract x from both sides, I'll get minus x. So now we have this in the same form as y is equal to mx plus b. The slope m is -1, and the y-intercept is 2. So if we do something like this, if the y-intercept is 2 and the slope is -1, that means we're going down 1 over 1. And we have a line that looks roughly like this. So here is the line x plus y is equal to 2. But what about if we wanted to look at x plus y is greater than 2? So where is x plus y greater than 2? Well, if I plug in a couple points, if I look at if x was 2 and y is 3, 2 plus 3 is certainly bigger than 2. 2 plus 3 is 5. So the point 2, 3 certainly satisfies that equation. Well, the point 2, 3 is up here. And it turns out that once we know that that one point is up there, we know that every single point on this half of this line, everything above and to the right of our line, is going to satisfy this equation. On the other side, if I wrote x plus y is less than 2, 2, 3 now does not satisfy that. If I plug 2, 3 into this equation, I'll get 2 plus 3 is less than 2. That certainly doesn't work. So the opposite side, down here, this is going to be where x plus y is less than 2. This is x plus y is less than 2, and this is where x plus y is greater than 2. So when we are graphing inequalities, all we have to do is essentially draw our line and decide which side of the inequality, which side of the line is the inequality going to be true. So these are called half planes. So we think of the entire xy coordinate system as just the plane, and a half plane is just going to be half of it. We're going to cut it in half with a line. And the method for drawing these is fairly straightforward. It's just like we did. What we want to do is we want to draw the graph of the equality. So we'll switch the inequality with an equal sign and we'll graph it. One helpful thing to do is whenever we see a less than or equal to or greater than or equal to sign, we'll use a solid line, and whenever it's just strictly less than or strictly greater than, we'll use a dashed line. And this just helps us remember, do we include the line in our solution or not? Then we test a point from one of the half planes. We'll just plug in some point that's on one side or the other. And once we test that point, we'll know which side of the inequality, which side of the line is the inequality going to be true on. Is it going to be the one either to the right, to the left, above, or below? We will know which side to shade. So let's go through a couple of examples. So let's graph 4x minus 2y is greater than 8. So first things first, we need to look at the line that separates our two half planes. So we're just going to go ahead and put an equal sign in between here. So this is the first step. So we need to graph this line. It'll be easiest if we put it into slope-intercept form. So let's move the 4x to the other side. I'll subtract 4x from both sides. And then I'll divide everything by -2. So divide by -2, divided by -2, and we get y. The -2's cancel. -4 divided by -2 is 2, and 8 divided by -2 is 4. So we now have, let's draw a better line, like this. Our intercept is going to be at -4. And our slope is going to be 2. So we will go up 2 and over 1. Up 2 and over 1. So this is going to be our line. It's going to pass right through these points. Let's come back and look at our original inequality sign, though. And because it's strictly greater than, we are going to do a dashed line. So and this will help us remember what the original sign was. So now we just have to see. Okay, we have 2 half planes. We've got the plane up and to the left, and we have the plane down and to the right. So the question is, where's my inequality true? Well, let's just pick a point somewhere. So right here, this seems like a good point. That's the point 1, 1. This is not on my line, and it's on one half or the other. So let's plug a 1, 1 into my original equation here. So if I plug a 1 in for x and a 1 in for y, is this still true? If I plug a 1 in for x, I get 4 minus 2. Well, that's 2. So the question is 2 greater than 8? Nope, certainly not. So this side is not the correct side. So we know that the side to shade will be this right-hand side. So this is going to be the side where 4x minus 2 is greater than 8. Cool. So that's how we graph an inequality. Let's do another example. We have y is greater than or equal to -3/4 x. So again, first we replace the inequality with an equal sign, and hey, this is already in slope-intercept form. And the intercept is just going to be 0. There's nothing out here, so we know that it'll pass through this point. Our slope is -3/4. So we will go, so rise over run, so down 3/4. So we have the line connecting these 2 points. We come back and we look at our inequality, which is y is greater than or equal to. So we'll do this with a solid line. And then again, we just need to pick a point on one side or the other. Let's pick this point here. So this point is 3, 0. It's 3 over and 0 up. So let's see if that makes this true. So I'll plug a 3 in for x and a 0 in for y. So 0 is greater than or equal to -3/4 times 3? Question mark. So the left-hand side, we don't have to do anything. -3/4 times 3, well, that's -9/4. This is a negative number. 0, and all negative numbers are less than 0. So this is in fact true. So the side that I will shade will be this side up here. And just to point out, because this is y is greater than or equal to -3/4 x, the line here is included. So remember that because it's greater than or equal to, there are 2 ways that this can be true. If y is greater than this, it includes that is this top shaded part. If y is equal to -3/4, well, that's this line. So when y is greater than or equal to, it is this entire upper half plane as well as the line itself. A couple of situations that we haven't necessarily addressed but are again fairly straightforward is what happens if we have a vertical line, so a line going straight up and down, or a horizontal line where a line is going straight left to right, and everything works in exactly the same way. And I think it's just easiest using a couple of examples. So I've written it down here if you simply want to remember it, and I'll and you can pause the video to copy that down. But I'm going to go through this in exactly the same way that I was doing before. So we want to graph y is greater than 1. Well, replace that with an equal sign. We want to graph when y is equal to 1. So if y is equal to 1, that means that the height of the function, y is always equal to 1. So that means that the height is always equal to 1. This is y is greater than 1, so we used a dashed line. And now we want to see which side of the line should we graph. So let's pick a point up here. Right there we have that is 0, 2. So y here is 2. So if I plug that into my equation, 2 is greater than 1. Yep, it passes the test. So we will graph everything up here. Notice that if I plug in a value down here, if I plugged in, say, this one, when y is negative 1, negative 1 is certainly not greater than 1, which is why we don't shade down here. We only shade on one side. Likewise, let's graph x is less than 2. Sorry, less than or equal to 2. Again, we'll just graph x is equal to negative 2. So x is negative 2 right here. So there are no restrictions on y. It doesn't say what y is, so y can be anything. So our line is going to be this guy right here. Since it's less than or equal to, I draw a solid line. And next, let's check, is it on the left side of this or is it on the right side of this? So let's plug in a point. Here, this is a nice point. We've got 0, 0. So let's plug x is equal to 0 into our equation. Is 0 less than negative 2? Nope. No, it's not. So we will graph the other side of our function. And the last thing that we'll mention in this video is that everything that we've talked about works even if what we have is not a straight line. So let's look at this equation here, or this inequality here. We've got x squared plus y squared is greater than or equal to 16. We apply the same method. We replace this with an equal sign. So we get x squared plus y squared is equal to 16. And when we look at this, this is the equation of a circle. So remember that with a circle, we can figure out the center. So since this is x minus 0 squared and y minus 0 squared, the center is at 0, 0. And the right-hand side is the radius squared. So if the radius squared is 16, that means the radius is 4. Okay, so because we have a greater than or equal to, we get to draw a solid line. And now we just have to decide, what side of the line are we going to graph on? Are we going to shade in? In this case, we can see that there's two places that we could shade. We could either shade inside, or we could shade outside of the circle. We just have to decide, do we shade the inside or the outside? And again, all we do is we test a point. We pick one point, plug it in. If it works, that's where we shade. If not, shade on the other side. This is a nice point, 0, 0. Nice easy point to work with. It's right on the inside. So let's plug this in here. 0 squared plus 0 squared, is that greater than or equal to 16? Well, 0 squared and 0 squared, that's 0. Is 0 bigger than 16? No, it's not. So we're not going to shade on the inside. We are going to shade the outside. So even when we have a nonlinear equation, when what we're graphing is not just a line, we still do the same thing. You pick a point on one side of the graph or the other, and you test it. If it works, that's where you shade. If not, you shade the other side.